Okay, so to find GFP, we're going to write down the matrix G, which is the 1, 0, 0, 2, and the matrix F, which is the -1, 0, 0, 1, and then the vector pointing at P, which is 4, 1. We're now going to multiply this lot together, and that's going to give us the vector pointing to this point GFP. I can choose to do this in whatever order I want. I can multiply together the matrix and the vector over here and then multiply that by this one. I could multiply the matrices together and then multiply that by the vector. It really doesn't matter. What I'm going to do is I'm going to multiply first of all this matrix and this vector. So I'm going to leave the 1, 0, 0, 2 out in front. When I multiply this matrix by this vector over here, I'm going to get -4 and 1 going in here. Oh, sorry for the glitch. -4, and again, third time's the charm, -4 and 1. Now if I multiply this matrix with this vector, I'm going to get -4 on the top and 2 on the bottom. And so, GFP is the point -4, 2. Now we'll have a look at part 3. We want to find a matrix Q such that GQP equals P. So let's first of all write this down. We've got the matrix G, 1, 0, 0, 2. Then we've got some matrix Q that we don't know being applied to P, which is 4, 1, and that's going to equal 4, 1. Now, this looks like quite a complicated problem, but let's think about this in terms of transformations for a second. 4, 1 has some transformation applied to it, which we're calling Q, and then another transformation applied to it, and we end up back where we started. So whatever it is that this matrix does, this one has to do the reverse of that. Now this understanding that we've built up, looking at our previous transformation matrices, comes in very handy here. Let's look at what this matrix over here is doing. It's not changing the x values at all, because 1, 0 representing our x values is still 1, 0 in that first column. In the second column, our 0, 1s representing our y values have become 0, 2s. In other words, nothing happens to x, x stays the same, but our y values double. That's the effect of this matrix over here. So if I wanted to do something which reversed that effect, my y values would have to halve and my x values would stay the same. So in the first column of my Q matrix, I've got 1, 0, x values staying the same, and in the second column I've got 0, 0.5, which halves my y values. And that's the answer to that question. More in the next video.